Good evening and welcome. We're going to wait just about another minute. I can still see some folks entering into our virtual lecture room this evening. So we'll get started in about 30 seconds. Okay. Thank you. Okay. Well, hello and good evening. And again, welcome everybody for participating tonight in our webinar. My name is Jessie Jones and I am the volunteer coordinator for Coast Watch. And tonight I am here with Steve Rumrill and very excited about tonight's program about kelp. I'm going to say a few words about Coast Watch, the Coast Watch program, and about Oregon Shores, and then we will get started. And I wanted to give a special welcome to everyone new joining us tonight. And I also wanted to thank the City of Coos Bay for helping us to promote this webinar. It's always great to have new partners to help us with our outreach. So thank you very much. So again, my name is Jessie Jones and I am the coordinator, the volunteer coordinator for Coast Watch. And Coast Watch is a program of Oregon Shores Conservation Coalition. Oregon Shores is a regional group that helps to protect the environment of the entire coast region, from the Columbia River to the California border, and from the crest of the coastal mountains to the edge of the continental shelf. In addition to organizing Coast Watch and citizen science, Oregon Shores tackles a wide range of conservation concerns, including land use planning, water quality, endangered species, shoreline management, and marine conservation. Through our Coast Watch program, volunteers adopt 1 mile segments of the Oregon shoreline, and Coast Watchers, who are our volunteers who I work with a lot, keep a watch for a wide range of natural phenomena and human impacts. And we also organize a number of coast-wide citizen science projects. So new volunteers are always needed, so contact me if you would like to be involved. This is the website for Oregon Shores, www.oregonshores.org/Coast Watch is our program, but you can find all about our programs here and our future webinars in the events tab of Oregon Shores. So we have been providing our volunteers and the general public with webinars since the pandemic began. Normally, I would be traveling along the coast, presenting in breweries and libraries and community centers, but here we all are. And it has been wonderful to be able to present these to a wider audience. For example, if we're talking to someone in Newport, we can be speaking with everybody along the coast. Tonight, Steve is with us from Waldport, and I am talking to you from Astoria, and I know that we have people here from all up and down the coast. So welcome, and I'm going to give a brief introduction to Steve. Steve is the shellfish program leader for the Oregon Department of Fish and Wildlife, and he has statewide responsibilities for management of a multifaceted program that encompasses policy development, resource assessment surveys, commercial and recreational fisheries, scientific research, and outreach activities for a diverse group of shellfish that inhabit Oregon's bays and estuaries, sandy beaches, rocky shores, subtidal reefs, and deep water habitats. Before joining ODF&W Marine Resources Program, Steve served as the chief scientist and research coordinator for the South Slough National Estuarine Research Reserve in Charleston, Oregon. He holds adjunct academic appointments at the University of Oregon, Oregon State University, and Portland State University, where he conducts scientific research in collaboration with faculty members and serves as an advisor to graduate students. Steve received his master's degree in marine science from the University of California at Santa Cruz and his PhD in zoology from the University of Alberta. Welcome, Steve. Thank you very much for being here. And I'm going to stop sharing, and then let's see, you may start sharing.
All right, great. Well, thank you very much, Jesse, and thanks to the members of Coast Watch and the other participants in this webinar. I'm very happy to be invited to speak with you today, and I look forward to sharing some descriptive stories really about the current condition and the disruption of the ecological dynamics in our shallow subtidal zones. So I'm not sure if I'm going to disappear when I touch the share screen, but before I do, I'd like to echo what Jesse just said, that it's an unusual but a welcome opportunity to talk to everybody up and down the coast. And I would, of course, prefer to be there in person and to be able to walk amongst my friends and colleagues and new friends and speak with you face to face. But in the situation we're in, I'm finding as we do more and more of these webinars that it is an effective way to communicate. And I hope to be able to tell a compelling story and make sure that, that you can have a chance to talk with me at the end as well. So I'm going to hit share screen. I don't know if I'm going to disappear here, but we'll see what happens.
Steve, if you would like to disappear, I think you can turn off your video on the bottom left, but you will be a little talking head on the side or on the top, which sometimes people like that, but it's up to you.
I'm okay. On my screen, I can see you and myself up in the upper right. Is that okay?
Yeah, that's great. And I can just see you. And so that's the most important part.
Good. Well, again, my name is Steve Rumrill. As Jesse said, I'm the shellfish program leader within the Oregon Department of Fish and Wildlife. And part of my job is to worry about and make recommendations for actions taken by the Oregon Fish and Wildlife Commission to address situations that pose problems for us regarding shellfish and their habitats. So I'm leading up to those kinds of recommendations, but I want to share with you the background situation that we're in right now. So I've titled this Calamity in the Kelp, Recent Disruption of Ecological Dynamics in the Shallow Subtidal Zone of Oregon's Rocky Shores. What I'm going to describe really are the ecological issues that are associated by this unusual massive marine heat wave and its contributions to changes in the status of our kelp beds, Seastar populations, urchins, and abalone in the Oregon Rocky Reef habitats. I'm mostly focused on the south coast, southern Oregon coast at this point. Oops, my slide's not advancing. So let me back up here. That didn't work there. So let me try this again.
And sometimes you have to, I've noticed with these, Steve, you may have to use your mouse to forward rather than your keyboard.
Mouse to forward. Okay, there we go. All right, great. Okay, so
but you have to share your screen. You have to share your screen again now.
Oh, sorry about this.
That's okay.
Let's see.
There's always a little bit of technical difficulties with these, so. Oh, okay. Yeah, there you go.
And it works?
There you go. Yep.
Okay, whoops, now going forward only. Ah. All right, here we go. There we go. Okay, so for outline, I'm going to describe really quickly, just in a couple of slides, the different perspectives about Oregon's nearshore systems, and then focus in on this nexus of non-normal events, beginning with the marine heat wave that's really been a harbinger of climate change along the coastline. I'll describe this calamity in the kelp community and describe the disruption in the populations of sea stars, kelp, urchins, and abalone. And then I'm going to end up just focusing back in on our rocky shores and then leave this open for some discussion and questions. Oops, going the wrong way. Okay, so when we think about nearshore systems, the scale at which we're thinking about depends on your perspective. Some of us come at thinking about nearshore systems from the perspective of the ocean. I'll call that the mega nearshore systems. And we think about the nearshore as the continental shelf, or the continent, or the California current, or perhaps the big California or Columbia River plume sweeping offshore from Astoria and up north and down into northern Oregon. Others of us think about the offshore more at the mesoscale, really focusing our attention on upwelling zones, or the issue of low dissolved oxygen or hypoxia, or now what we're recognizing as these ocean acidification hotspots, or the multiple stressors associated with ocean acidification and hypoxia together. And we also think about these Oregon coastal current, coastal fronts, shown on the right side here. This is a very nice map that just shows the extent of fresh water and turbidity flowing down the Oregon Coast Range through these multiple watersheds, and leaving a telltale mark in increased turbidity and fresh water, diluted salt water along the coast, really comprising the Oregon coastal current. But many of us think also about the nearshore at the micro scale, way down into the geomorphology of the coast and its interactions with the Oregon coastal current to form headland retention areas where particles and turbidity, but also zooplankton, small fishes, marine invertebrate larvae are retained for long periods of time. The influence of these retention areas on nutrients and the opportunity for phytoplankton blooms to form up. And then others of us think about even closer to shore, the surf zones and the swash zones, as we're thinking about king tides, you know, the big surf pushing up the combination of high tide and surf together into those big swash zones. And then we also think, of course, about the shallow subtidal zone and the intertidal zones. So when we use that term nearshore systems, it really depends on the spatial scale and the processes. If we look at the technical definition offered up by the Coastal and Marine Ecological Classification Standard, or CMEX, that recognizes the marine waters as a special system within CMEX. And the nearshore is a subsystem, and it's classically defined, or really technically defined, as from 0 out to a depth of 30 meters. Along the Oregon coast, that's a very narrow strip along the continental shelf. And so it's a very narrow area, shallow depth out there. Oops. Now, when we think about this from the perspective of many of you are, as you're working to put together proposals for potential areas to be considered in the Rocky habitat management strategy, I urge you, and really this is the take home here, I urge you to give consideration to the ecological conditions and communities that occur in the shallow subtidal zone as you put together those proposals. So even though many of you are focused on the rocky shores and the rocky intertidal zone, I want you to also just think a little bit about the submerged rocky habitat. That's defined as the rocky habitat below extreme low water out to the deepest limits of the Oregon Territorial Sea. Now, in the context of the Oregon Rocky Habitat Management Strategy, we're asking, the state is asking you for you to give consideration out to a depth of about 15 feet below mean low or low water. So this would give some consideration to the submerged rocky reefs, the shallow rocky subtidal zone, the kelp beds, understory algae, those communities as well. And so I'm going to return to this at the end of my talk, but I just wanted to introduce that right up front. Oops. Okay. What does that look like? From the bird's eye view, over on the left, just a diagram showing the Territorial Sea Plan definition of rocky habitats. So over on the left in the green, that's the uplands, and then the vegetation line delineating the uplands to the rocky shores. And those rocky shorelines, intertidal, then sweep down through the intertidal zone out to extreme lower low water, and then extends out into the submerged rocky habitat, some distance, as the state is asking for, out to about 15 feet. The same thing exists for our offshore rocks and islands. So surrounded by, offshore rocks and islands are surrounded by an area of submerged rocky habitat, the shallow subtidal zone. And in some cases, that shallow subtidal zone doesn't quite break the surface, so there could be some submerged rocky reefs. Over on the right, the air photograph of Rainbow Rock down in southern Oregon, just north of Brookings, shows an example of that, where you can see the green in the upper right of the terrestrial environment and cliffs coming down to a cobble beach, and then the red line delineating that polygon of intertidal habitat. But then this yellow area would surround then that associated submerged rocky habitat. So you may want to just give some consideration to the types of ecological communities and dynamics that are taking place in this shallow subtidal zone, because of course it's going to influence what's going on in the rocky intertidal habitats as well. Okay, so I'm going to shift over here now and start to talk about this unusual series of events that have taken place over the last several years. I'm calling this really a perfect storm, or the nexus of non-normal events. And they include, first, elevated seawater temperatures, this marine heat wave that we've come to know now popularly as the blob of warm water, really recognized originating back in 2012, recognized in 2013, very strong through 2015, developed into a persistent marine heat wave that's persisted over several years, including up till now. Coupled with that, another non-normal event, this massive Seastar wasting disease, first recognized in Washington and California in 2013, sweeping up right after that into Oregon, and just resulting in the massive heavy mortality of millions of sea stars of multiple species, 18 to 25 species of sea stars that have suffered heavy population losses through that time. And I put the plus on there because we still have sea star wasting going on today, just not as heavy. Also, another non-normal event concurrent with all of this, we've seen massive heavy recruitment of purple sea urchins. By recruitment, I mean the appearance of the smallest juveniles that would show up in quantitative surveys of the populations. That was preceded by larval settlement and growth of those microscopic post-larvae into smaller juveniles. But then as they recruit into the population and we can begin to notice them and count them, they become part of the population. And that occurred in 2013 to 2014, followed by growth and change in behavior. And that's occurring right now at an alarming level that is really resulting in very high numbers, unprecedented high numbers of purple sea urchins, not only changes in their abundance, but also changes in their behavior and changes in their depth distribution. Typically, we think of purple urchins as being in the very shallow subtidal zone and occurring in the lower rocky intertidal zone. But now the purple urchins are extending their depth range down into deeper water, down to 40, 50 feet below sea level. And then also now another non-normal event, the decline in bull kelp, the Nearshore lutkiana, not everywhere on the Oregon coast, but at some key areas that we've been keeping an eye on. And that was noticed beginning 2015 through 2017 and persisting into losses and decline of kelp into the year 2020. So we've got this perfect storm of non-normal events that have contributed to trouble. And what that has turned into is all of these events coming together and contributing to the decline of red abalone populations in Northern California and Oregon. A real problem for us and for me as a manager of the shellfish program to see what we can do about that. Oops. This flow diagram just shows some of these key players and events. So beginning on the left, the marine heat wave, contributing perhaps to sea star wasting and mortality, the sea star wasting event, and also contributing to declines in kelp and understory seaweed. And the thoughts are that sea star wasting may be some related to the high, heavy recruitment and increases in purple sea urchins, and the heavy numbers of purple urchins, coupled with the declines in kelp, have led to a decline in the amount of drift algae available for grazing by urchins, but also lack of drift algae available for grazing by our red abalone. And subsequently, now we're seeing declines in red abalone. We're not sure about the causative nature of these relationships between all of these events, but it seems like there's a pretty strong relationship between them. We just don't have proof of that in an experimental or empirical manner. Okay, just thinking real quickly now, focus in on the marine heat wave. So I don't need to let y'all know, but in the situation we're in now, global climate change is happening and is real, and the planet has warmed and is continuing to warm. Lots of records are showing greater and greater atmospheric temperatures and increasing ocean temperatures. The graph in the middle shows the land and ocean temperature anomalies, or the greater than expected, and it's getting warmer and warmer and warmer. The diagram on the right shows the sea surface temperature change throughout the world, and you can see that there are lots of orange colors in the 1.5 to 2.5 degrees Celsius or Fahrenheit temperature increases. The Earth is in climate and ocean is getting warmer. This series of images just shows the maturation of that warm marine heat wave, recognized first back in July of 2014 and given that weird name, or that ominous name, of the blob, the big blob of warm water. You can see the red color here just persisting into 2015, into 2016, 2017. We had some La Nina conditions with cooler waters shown in the green down below there. But then, and that persisted over into 2018. But then by 2019, we were back into El Nino conditions again. 2019 El Nino conditions. If you look up on the coast of Alaska, Southeast Alaska, there's that big warm water blob again. August of 2019, really recognizing it as a major marine heat wave, persisting through September and November of 2019, and then disappearing, or at least diminishing in January of 2020. And then through this year in the spring, warmer waters off that coastline, through the summer, again, warmer water, and through July and August, September, also warmer water. We've had a major marine heat wave that has influenced the marine waters and productivity along our coast. Good to hear that we're entering into La Nina conditions now, and we're keeping our fingers crossed that some of those poor conditions may be shifting, but that's the situation that we're in right now. So rising nearshore ocean temperature puts stress on organisms, physiological stress on the organisms in terms of being able to tolerate the warm temperatures, but also in the internal physiological mechanisms for processing food and respiration, for dealing with heat stress, reproductive output. All kinds of physiological processes in marine organisms are related to temperatures. We're also seeing range shifts, some species from the south moving up into the north, and also some unexpected species moving from the north down into the south. We're seeing regional impacts to biotic productivity, and there's large uncertainty regarding the timing and intensity of upwelling in the California current. That upwelling is a combination of currents sweeping from the north to the south, coupled with winds driving those currents, and changes in the nearshore oceanic climate and regional climate will, of course, have a great influence on the strength, intensity of upwelling in the California current. We're also seeing manifestation of climate change, ocean acidification. And this is the CO2 levels raising in the atmosphere, but then also diffusing into ocean waters and changing the pH balance in the ocean, driving it more towards the acid side than the base side. And we're seeing now, time after time, the susceptibility of embryos and larvae, in some cases the behavior and the ability of fish to track their prey, some shifts in food webs associated with that, all kinds of things associated with the changing biogeochemistry of our nearshore ocean waters. And then finally, also just beginning to get some sense, and maybe this is part of that story that we're seeing on the Southern Oregon coast, that the combination of marine heat waves and changing climate conditions as they manifest in the regional nearshore areas could be leading to changes in the ecosystem structure along our coastline. Could just look really quickly at a nice slide put together by my friend and colleague Lori Weinkamp with NOAA. She documented biological responses to the shift in nearshore ocean conditions. In 2015, along the Oregon coast, we saw species range extensions in California, Washington, Oregon, all the way up into Alaska. In 2016, we saw the arrival of some exotic species on our coastline and return of the squid fishery to Oregon. 2017, again, some weird exotics. And those of you walking the beaches will remember the explosions of pyrosomes, those weird kind of hot dog looking colonial critters along the coastline, all the way from Alaska, Washington beaches, Oregon beaches into California. 2018, again, another resurgence of the squid fishery on our coastline, and also seen warm water fish in there. And 2019, some weird tropical, subtropical fishes showing up. So the types of impacts, species distributions have been expanded, some from the West Pacific to the east, some southern species moving to the north, and in some cases, some northern species moving to the south. We're seeing changes in the depth distributions of species, changes in productivity, some up, some down, changes in the mortality, the lifespans of them, also changes in their reproductive timing and changes in behavior. All of these contribute to what we're seeing as, in some cases, subtle shifts, others more marked and dramatic shifts in ecosystem composition and structure. Let's go back to this flow diagram. So beginning with the marine heat wave, one strong arrow here aiming down at declines in kelp and seaweed. And so we're looking at that. So again, here's that marine heat wave documented in 2014, focusing in here on the Oregon coast. What does that mean for our bull kelp, Nearshore, along the southern Oregon coast? Bull kelp is this fantastic algae, very productive brown kelp that is attached to the rocky subtidal areas and rocky shores and grows at a phenomenal rate up to the surface, where we're used to seeing the float and the blades and the stipe lining out with the currents and tides, providing sheltered water that's very productive habitat for fish, for invertebrates, for zooplankton, for the production of detrital material, retention of slowing of waters and retention of nutrients. Very nice, protected, rich, ecologically valuable habitat. So bull kelp, as I mentioned, inhabits rocky substrata in wave-exposed areas, and it can extend down to a depth of about 40 meters below the surface. This is an annual species. The individual blades can persist a little over a year, and they produce spores. And the spores, once they settle out and begin to grow, can really grow very quickly, 10 centimeters, 15 centimeters per day. But I have to point out that the young spores, just as they begin to grow up and turn into small understory kelp, are very vulnerable to grazing by red urchins and by purple urchins. Now in Northern California, very well known and documented, there's been substantial bull kelp decline. And the photographs on the left in A and D, I don't know exactly where the site is in Northern California, but you can see a photograph with extensive blades of bull kelp there in A, virtually all gone in D. Underwater, rich understory of bull kelp and understory seaweeds. And in panel E, just grazed by purple urchins down to nothing left but the stipes. Coupled with that, so the warm seawater in Northern California is thought to have killed the kelp and led to some massive declines back in 2015. Coupled with that, we've also seen massive declines in the number of sea stars. Of course, in the rocky intertidal zone, the popular ochre stars that are easy to see and count. But in the shallow subtidal reefs, these large predatory multi-rayed sea stars, Pycnopodia, the sunflower star, or Simpson's star, solasters, crossasters, a whole series of big predatory sea stars, soft-bodied sea stars, have also suffered massive mortality. And these graphs over here on the right just show the numbers before sea star wasting. They just decline down to virtually zero. No Pycnopodia, none of the sunflower stars. Very rare to find them now. And concurrent with that, the graph C on the bottom shows the abundance of purple sea urchins at all of these sites in Northern California increasing concurrent with the decrease in Pycnopodia. Is that a cause and effect? Not clear exactly, but it may be. Well, what about on the Oregon coast? The two photographs on the right show that same picture out at Port Orford. In 2014, there was lots of bull kelp, but in 2016 out at Orford Reef, very little surviving bull kelp. So bull kelp, we know, are already highly variable in space and time along the Oregon coast. And over the past several years, we've seen the spatial extent and abundance dramatically reduced at some sites after the marine heat wave. For example, at Orford Reef and also at Humbug Reef on the southern coast. But we've also seen increased spatial extent and higher density of bull kelp at other areas like the Rogue Reef, Redfish Rocks, or in some parts of Cape Arago. And other places along the Oregon coast, up here in the central coast, looks like it's been static, Depot Bay, for example. So we really have to ask ourselves as coastal ecologists, what's responsible for the recent changes in bull kelp beds along the Oregon coast? It's not at all clear. Sarah Hamilton is a graduate student up here at Oregon State University, and she's been documenting the changes in Oregon's bull kelp beds using satellite imagery, and pioneered a technique to do that. And here's some graphs from her recent manuscript. As I mentioned, we've seen no consistent change in bull kelp in Oregon since 2014. There's been a decline at the Orford Reef, shown on the far right, from 2014 till now, but an increase at Arago, Redfish, and Rogue Reefs, shown in the other graphs, and also no change at Depot Bay. So we're scratching our heads. What's the story with bull kelp? Now, also want to start off and describe as well Seastar wasting. You know, very important event for us, those of us who are ecologists in the Rocky Shore. Beginning back in 2013, we saw, as I mentioned, millions of sea stars losing their lives in the intertidal zone. And I want to just let you know, of course, that occurred in the shallow subtidal zone as well. This photograph shows the ochre star, Pisasterocrasis, which we know is an important predator in the intertidal zone. And the feeding biology of Pisasterocrasis has been very well documented in the scientific literature and in the popular literature as they feed upon mussels and barnacles and snails and limpets and chitons, other sea stars as well. They're a very important ecological force in the intertidal zone. Seastar wasting syndrome and the disease started in California and Washington, or at least first noticed there, and then noticed in Oregon shortly thereafter in 2014. But this was a massive event spread from Alaska down to Baja California, affecting greater than 20 species of sea stars, perhaps the greatest marine disease event ever documented, and still unknown. Originally thought to be caused by a virus, a parvovirus type of virus, but some more recent evidence perhaps casting some questions. So really unknown what the actual causative event was. And as I mentioned, we're still seeing evidence of manifestation of seastar wasting going on along the Oregon coast and Washington, California as well in 2020. Here's the story for Oregon. So seastar wasting and rapid mortality of Pisasterocrasis in the intertidal of Oregon in 2014. At that time, substantial losses on the scale of 60 to 98% declines of Pisasterocrasis along the Oregon coast. Multiple study sites as shown in that central map, and then the graphs over here on the right, just showing the density declining at all of those study sites along the Oregon coast, very rapidly as well once they occurred. Just a matter of months, 4 or 5 months or so to go from healthy populations to virtually disappeared. Now, you've probably heard as well that we've had some hot spots where we've had some very good recruitment. And this photograph that we took down at the north jetty of the Siuslaw River, where there are just hundreds and hundreds in this photograph of small Pisasterocracis that recruited back in. So we've seen some recovery of some stars like Pisasterocracis coming back up, and that's encouraging news for some species at some sites in the intertidal zone. And there's something weird about Northern California and Oregon. This weird graph on the left shows study sites stretching all the way from Alaska through Washington, Oregon, Northern California, Central California, and Southern California, and the Channel Islands. And the dark blue colors show the abundance of juveniles. So we're seeing most of those dark blue colors in Oregon and in Northern California. So we've seen some recovery of Pisaster as promising in Oregon and Northern California, but not at other locations. And it's precisely these weird places where we're seeing recovery of the ochre Seastar, where we're also seeing the decline in bull kelp. And we're scratching our heads trying to figure out, is there any relationship between those? Now, when we think about the massive mortality of sea stars, because they are such important ecological driving forces, keystone predators, if you will, that control the dynamics in the intertidal zone, you got to think about this, that the removal or mortality of those top predators will lead to a trophic cascade of linked events. When the top predator disappears, that's going to allow for the prey populations to make adjustments in the absence of that predation pressure. So we could expect that with the mortality of sea stars in the intertidal zone, some changes in mussels, changes in the amount of predatory snails and barnacles and limpets, and perhaps some shifts in the seaweeds that they graze upon. So we expect to see some ecosystem food web changes associated with mortality. And the classical expectation shown in this diagram here, that with removal of Pisaster from the intertidal zone, the graph on the left shows the situation normal. So with sea stars preying upon mussels and the mussels extending up into the mid zone, a diverse community of barnacles and chitons and snails and sea anemones in the low zone leading down into the shallow subtidal. When those important predatory Pisasterocracis are removed from the system, the expectation is then the mussels free from predation would extend down and dominate the rocky intertidal zone. Well, is that what happened? In some cases, yes. In some cases, no. Again, a big group of folks, Oregon, California, working together to try to document that and see what has happened after the Pisasterocracis were removed from the system. So this map shows the location for all of those survey sites shown here in green, extending from Cascade Head and Otter Rock through Oregon down into Northern California, Point St. George and Shelter Cove, sweeping down into Bodega and just north of San Francisco and south of San Francisco into Año Nuevo, into Monterey Bay and down the Big Sur coast into Southern California. A very large network of sites where ecologists are looking at the dynamics of these systems in the absence and now partial recovery of Pisaster. And at several of those sites shown in pink, there are actual experiments, field experiments taking place. Well, what's happened? And so what that big network of monitoring has shown is that there's been a high variability or heterogeneous spatial mosaic in the takeover by mussels. So the graph or the photograph right in the middle shows that the mussels moved greater than 1.5 meters downward at Port Orford as expected. So that seemed like, okay, the intertidal zone at Port Orford is acting as we expect. But over here in Monterey Bay, my old major professor at UC Santa Cruz made the prediction that there'd be no change in the mussels. And that was what was documented. So he's gleefully pointing out that there's been no change at all in where the mussels were expected there. And the graph over here on the left just shows those areas. So the dark blue areas are no change. The red areas were downward movement of a couple of feet. So there's been, and the colors aren't all the same. So there's been no change at some sites, 1.5 feet or so changing in others, about a foot or so changing in other places. There's been a spatial variability in the recovery of the mussel beds. And that's curious as well. So my major professor really just was asking me tough questions. He recently passed away, and in his tribute and eulogy, I raised this back up and thanked him for asking these tough questions, but lamented that he's no longer here to help advise me on how to figure it out. But that question really, how do the ecological dynamics of echinoderms differ along their biogeographic range? Keep in mind, these species are biogeographic ranges, in many cases extending from the Aleutians and Alaska all the way down the coastline, west coast to California, sometimes extending into Baja. So they have the species level capability to deal with a wide range of ecological conditions. How do we expect their dynamics, their ecological performance to shift along that biogeographic range? And we have some perfect opportunities, like this photograph of the area, excellent study site at Middle Cove, Cape Arago, to look at some of these dynamics in the intertidal zone and also in the submerged rocky subtidal zone as well. Well, what about as we move into that shallow subtidal zone, let's think now about one of those big multi-rayed voracious predators, the sunflower star, Pycnopodia helianthoides. Their populations were severely affected by Seastar wasting syndrome, to the point that it's very rare to find any at all. We do have a few, less than 10 observations of individual sunflower stars now over the last 5 years along the Oregon coast, when they used to be abundant in the intertidal zone, shallow subtidal zone, and into deeper waters, sometimes even coming up in the commercial crab pots. And here, just this striking contrast showing very abundant gathering of sunflower stars in Vancouver Island, and then 3 weeks later, all gone. Did they all die? Well, there's a lot of evidence to suggest that yes, they all did die and disintegrate, but they also do migrate and move as well. So this isn't definitive that every star on the left died, but their numbers are greatly, greatly, greatly diminished. And that's been documented in surveys showing the massive mortality of sunflower stars along the West Coast. So monitoring observations shown in yellow points up and down the coastline of British Columbia, Washington, Oregon, California. And you can see the massive decline in Washington on the far right. These graphs go from 2004 to 2017, but 2013 to 2017, massive decline in Washington. 2013 to 2017, massive decline in Oregon. Same thing in California, 2013 to 2017, massive decline of sunflower stars all along the West Coast. So we're at the point now where really we have almost 100% declines in California and Oregon, and about a 99% decline in Washington. And none were observed in 700 trawls done by the National Marine Fishery Service in 2016. So their numbers are really down. So that's leading to this, back to our flow diagram again, is the marine heat wave that may be partially responsible for Seastar wasting and mortality, killed off Physastrocracis. Some of them have come back, but also killed off the sunflower star, which does not appear to be coming back. Well, what's the relationship between the loss of sunflower stars and the recruitment of, and what we're seeing now, an increase in sea urchins? So sunflower stars are known to prey upon purple sea urchins. And here are just some photographs of them in the wild. And without the sunflower stars as predators, perhaps we were now seeing the purple urchins released from predation pressure to the point where they can grow and expand out and graze. And then when the food supply, the bull kelp and understory algae disappears, then the purple urchins change their behavior and begin to move and migrate and accumulate in very high densities, and what we call now as urchin barrens, extend out of the cracks and crevices and tide pools into deeper water, moving down where they compete directly with abalone and compete with the red urchins as well. So we're seeing some very dramatic changes in the population and behavior of purple urchins. Well, what do we know about purple urchins in Oregon? Oregon has a viable commercial sea urchin fishery. In fact, we have the most lucrative and productive sea urchin fishery along the whole West Coast. The urchin fishery, commercial urchin fishery, is centered on the southern Oregon coast and gathers both red and purple urchins. This is a dive fishery with an annual harvest of about 500,000 pounds per year, focused a little bit in Depot Bay, somewhat in Charleston and around Cape Arago, but heaviest down in Port Orford, off Gold Beach at the Rogue Reefs, Orford Reefs, Humbug Mountain, and extending down the coast into Brookings. Vast majority, though, between Port Orford and Gold Beach. Keep in mind, the urchins occur in the rocky subtidal habitats in rocky areas that support kelp and seaweeds as a source of food. And the grazing by big red urchins and purple urchins shown in the left then is converted by the urchin through its physiological process into gonads. And then the gonads are harvested as uni and are a delicacy in sushi. And one of my favorite sushis, very strong flavor. I love them very much. So that's sea urchins, are uni. Here's a quick history of the commercial red urchin fisheries landings in Oregon. I arrived in Oregon at the South Slough Reserve in Charleston in 1990. And at that time, we were at the peak of about 92 permits active down the southern Oregon coast, almost 100 businesses harvesting urchins. And they were picking up 10 million pounds. You know, that's a lot of urchins being harvested off the southern Oregon coast. Very rapidly, there was a request put in by the urchin fishery that was centered in Oregon to please limit the number of urchin harvesters. And Oregon Department of Fish and Wildlife took action to cut that number in half, basically down to 46 permits, permitted dive operations in 1989. And then in 1995, that was further reduced down to 30 permits as the urchin population was slowly being harvested and removed by the commercial industry. And then back in 2014, under my watch, we further reduced that down to 15 permits. That's where we are now. There are only 15 permitted operators harvesting red and purple urchins on the southern Oregon coast. Now, at that time, you can see the graph on the bottom, the urchin survey date. I took over the shellfish program in about 2011. And because this is an important issue to me, we've made sure that we've found the money to do quantitative surveys down the Oregon coast and to get some good numbers there. But back in 2011 and 2014, the densities of purple urchins were very low at that time. But our surveys in 2016 showed a dramatic increase. And our last quantitative surveys last year in 2019 showed a dramatic increase. Our 2019 survey showed 350 million new purple urchins at the Orford Reef alone. Dramatic numbers of purple urchins, unprecedented in our history. That made the big news, NBC News, swarm of sea urchins wreaking destruction along the West Coast. And not quite accurate that the creatures are now spreading from California to Oregon. Of course, urchins don't walk up the coastline. They reproduce by releasing eggs and sperm, have planktotrophic, microscopic, drifting larvae that will drift for about a month or so in the nearshore waters and then settle out in a new habitat. And if that's conducive to their survivorship and growth, they'll feed and then grow up. So that's what we're seeing really is propagation of the populations by planktotrophic larvae settling in new places in high numbers. Well, we have to ask that question. Is release from predation by sea stars, in particular by the underwater subtidal big predatory sea stars, is that at least partially responsible for the dramatic increase in the numbers of purple urchins along our coast. Some big experiments have to take place to figure that out. Now, there's a link between what's going on with the loss of kelp, the dramatic increase in numbers of urchins, the decline in predatory sea stars, coupled with the decline, sad decline that we're seeing right now in our populations of abalone. In Oregon, we've got flat abalone, Haliotis wallolensis, and we had a commercial fishery 2001 to 2008. That was one in recent history that many of us will remember taking place down along the coast. But before that, there was also a commercial industry fishery just for a couple of years on Haliotis rufescens, the big iconic red abalone along our coast. We also now have some confirmed sightings and observations of the pinto abalone, Haliotis kamchatkana, along our coast as well. Very unusual. I don't have any data to talk about there. But anyways, a few species here that were historically important commercially, but have persisted as small patchy populations along the Oregon coast, and they're of great interest to recreational divers. Whoops. I won't go into it here, but the Oregon Department of Fish and Wildlife has taken management steps to help conserve the populations of red abalone along the coast. And that's all taken place really starting back in about 1953. But by 1959, there were rules established for the recreational fishery. They allowed initially a commercial fishery, recognized that was unsupportable immediately and shut that down a couple of years later. And then even went through back in 1965 to 75 and again in the early 90s, spawning programs to perhaps enhance the populations and try to bolster the fisheries. And we're giving some consideration to some more of those actions now. The Southern Oregon Coast abalone fishery takes place along the south coast in our shallow kelp beds. And about 50% of the harvest takes place by divers who are scuba diving. About 28% are free diving, snorkel diving, and about 28% or so, and about 22% are harvesting abalone from the shoreline in the intertidal zone. ODFW, up to several years ago, offered about 300 permits per year. And from those 300 permits, sport harvesters took about 190 abalone per year. That was the average from 2007 to 2016. In contrast, California, where the center of the population is in Northern California, issued 25,000 permits per year compared to 300 in Oregon. And of those, about 240 individual abalone were taken per year, average 2002 to 2015, and they do not allow scuba. So you can see that the Oregon fishery was much, much, much smaller. And some of that recognized that the population is really very much diminished in Oregon naturally. The natural biogeographic range of red abalone extend up to about to Cape Arago, Sunset Bay. And so that's their northern limit, and their population density and abundance is very much reduced on the Southern Oregon coast compared to Northern California. Why do people want to harvest abalone so much? Well, it's not really so much for the meat, even though the abalone steaks are delicious, but it really is the thrill of the harvest and the beautiful trophy shells. Red abalone are the world's largest abalone, and like many species, they reach their greatest size up at the northern limit of their biogeographic range. So red abalone being the largest abalone in the world, and Oregon being the largest or the most northern extent of their biogeographic range, that means that the world's largest abalone occur in Oregon. And that's the case. The world's record, which is over 12 inches, 12 and 5/16 inches, was harvested off the Oregon coast. So trophy hunting for red abalone is really the popular allure. And we're trying to do what we can to shift this from a situation where larger numbers of small abalone would be taken to perhaps a fishery that would focus only on the very fewest, largest abalone. We've been documenting the low densities of red abalone for several years now with divers. And this diagram just shows our belt transects, which we established in the shallow subtidal zone. So we established a long transect and send divers out there to count everything that we can. So we're counting urchins, Seastars, abalone, and recording all of that down on these regular belt transects, same kind of way that they do that in Northern California. We've adopted their methods. I mentioned that one of the problems for red abalone in Oregon is that the densities are very low. First, they naturally occur in low densities at the northern limit of their biogeographic range. And now we have these current situation with very poor environmental conditions in the shallow subtidal zone. At the same time, Northern California has put a prohibition on their harvest. And so there are folks from California who are used to going harvesting abalone there who now want to come to Oregon and harvest. So Oregon has taken the steps to prohibit the sport harvest here in Oregon until we can come up with a reasonable regional red abalone conservation and fisheries management plan in cooperation with California. This graph in the center here shows the red abalone densities in California historically 2012 to 2016, up at about 0.44 abalone per square meter, and then how that dropped in California to below 0.2 per square meter and in 2017. And the red horizontal bar coming across shows that level of 0.2 to 0.15 abalone per meter squared. That's what we're thinking is vulnerable to collapse. When the populations get lower than that, they're subject to situations where it's very difficult for them to get together to reproduce. The low densities make it hard for individual abalone to find each other. So fertilization success in these free-spawning animals goes down. And they're also vulnerable to overharvest when they gather so closely together in efforts to reproduce. Well, where is Oregon? Back in 2015, we were well below that threshold. So we recognize that our patchy, low densities of red abalone are very vulnerable to collapse. So factors that are contributing to the decline of abalone along the Oregon coast. First, these low densities, they result in poor reproductive success. The clustered abalone, as I mentioned, are easy targets for harvest. There's very little food with the decline in kelp beds and decline in understory algae, very little drift material that works its way into the protected cracks and crevices where red abalone, pinto abalone typically live. The kelp beds are reduced at some sites after the marine heat wave. And we've also seen this increase in purple urchins, which compete directly with abalone for food. The Seastar wasting disease really is the absence of urchin predators, so perhaps has contributed to the abundance and heavy recruitment of urchins. And also the fact that sea otters are missing from the rocky habitats. And there's, as you probably know, a renewed interest in exploring the implications of sea otter returns. So management actions, the Oregon Department of Fish and Wildlife suspended abalone harvest for the years 2018 to 2020. And we're going back to them now to request to extend that prohibition of sport harvest for 3 more years into 2023. We're working to develop an abalone conservation and fishery management plan to cover the future. And we're under instruction from the Fish and Wildlife Commission to go ahead and do that, take what steps we need to do to conserve these populations in the shallow zone, but also allow what they call a de minimis or no effect fishery. Try to identify what level of fishery harvest would be acceptable to not put these populations at greater risk, but not completely shut off the harvest. The proposed lift of the sport daily catch limit for purple urchins and also establishment of unrestricted harvest of purple urchins in the subtidal zone. Those are perhaps a management step that we're considering that may alleviate some pressure on them. And we're also in discussions, they're underway to consider some kind of localized efforts to reduce urchins at special management areas, perhaps at some special conservation areas or beginning at some pilot areas, marine research areas. Okay, so the current situation is complex and connected. And the current situation is that we have unusually high densities of purple urchins along our coast, and they consume most of the drift algae and graze any of the available kelp. Okay, not at all sites, but at certain sites. And now the purple urchins are extending into deeper water habitats. And we're thinking that the grazing by purple urchins may contribute to the starvation and demise of red abalone, perhaps flat abalone, and perhaps even somehow related to the now new appearance of pinto abalone. The current situation is dire. It also includes the absence of predatory sea stars, and perhaps the long-term loss of otters along our coast may reduce the predation upon purple urchins. The purple urchins, we know, are long-lived. They have lifespans over 50 years, and they can survive for long periods of time as virtual zombies without food. So they can absorb some of their nutrients directly from their external soft skin below the spines. But what little food they can find to get by and scrape out, they can persist for a long period of time with very little food. Urchins, as we know, have highly dispersive planktonic microscopic larvae. There's one shown up in the upper left, and they can sweep in and recruit down onto the bottom from parent populations located many, many, many miles away. So it's not just localized dynamics. We know that they can disperse from great distances. And then finally, just recognizing that local reduction of urchins most likely will be ineffective against future larval dispersal and recruitment events. We may be able to put a dent in the population of adults at a site and see perhaps some recovery of kelp at that site. But we have to recognize that localized removal of adult urchins won't stop the influx of new planktonic larvae from sweeping in from distant populations. The situation continues, so we have high densities of purple urchins, and they can transform subtidal habitats into barren areas where we have very high abundance of urchins. They're grazing whatever is available and moving down into deeper areas. These barren areas may represent alternative stable states that could persist for years to decades along the coastline here. Our previous large-scale purple urchin populations were observed along the West Coast in the 1960s and in the very strong El Nino years of 1983 to 84, and they changed and righted themselves in essence. So it's possible that we're seeing a resurgence of conditions that we've seen a few times over the past decades. But right now, the current magnitude of the purple urchin population along the Oregon coast is unprecedented in our recorded history. So I want to finish off just speaking a little bit about the possible ecological role of sea otters in the Rocky Reef. And as I mentioned, there's a resurgence of interest in looking into the possible implications of recovery of otter populations. So sea otters are recognized as very important top-level keystone predators, and they prey upon a very large variety of shellfish, including urchins, but they also eat crab, abalone, clams, shrimp, other marine invertebrates. And like the sea stars that I described earlier, the foraging by otters creates this trophic cascade through the food web that has an influence on our communities. Sea otters occurred along the coastline of Japan and Russia and throughout the Aleutians, Alaska, into British Columbia, down through Washington, Oregon, California, and into Mexico historically. But then they were hunted for their fur in the 1790s through 1840s, 1850, and virtually brought to extinction, localized extinction along the Oregon coast. And field experiments have shown, and observations have shown that areas where sea otters are present, the predation by otters upon urchins and other grazing animals leads to a situation where we can have understory kelps and understory seaweeds. So without otters. We have situations where you can have urchin barrens, but kelp is allowed to recover in cases where urchins or otters are present. Again, just a couple other photographs showing some measurements in these situations, but just making that point that where sea otters are present, you can have luxurious bull kelp beds and giant kelp beds with their associated understory algae and diverse communities of invertebrates and fish. But in areas where otters are absent, they lend themselves towards these urchin barren areas. Earlier efforts were made to reintroduce otters to the Oregon coast back in the 1970s, 71 or so. A fairly large effort was made to bring sea otters into southern Oregon coast. And for whatever reason, those did not persist. So I just wanted to raise that up, that that's another factor in all of these communities that I'm talking about. So my final thoughts here is that we're in a situation where multiple stressful events have converged to contribute to an increase in urchins that's coupled with declines in sea stars, declines in bull kelp at some locations, and declines in red abalone. We have a need to understand these ecological communities that have complex trophic relationships. We need to understand these ecological communities as they interact with their whole food web, both in the intertidal zone and the shallow subtidal zone. We have a need to conduct long-term monitoring, directed empirical research, and also to define and design effective management actions that are driven by science, and that we can make use of special marine management areas, conservation areas, research areas to do these experiments. So finally, I want to just finish off by right where I started. We're in the process now here in Oregon. We're calling for proposals and amendments to the Rocky Habitat Management Strategy. And I just wanted to take this opportunity to just describe the situation, kind of a dire situation that we're in now along the southern Oregon coast in the submerged rocky habitat located in the shallow subtidal zone, immediately adjacent to the rocky shorelines and rocky intertidal zone areas that are under consideration. So I just wanted to take the opportunity to share some stories and images about what's going on out there. No solutions at this point, but just let you know that we're aware, concerned, and doing what we can to follow what's going on there. And I urge you also to just take some of the imagery and stories that I just shared with you into your own consideration as you work to put together those proposals. Okay, so I think at that, I'll just leave it open then for questions and discussion. And thank you for the opportunity to speak with you today. And I'll do my best to answer any questions you may have. So thanks a lot.
Thank you so much, Steve. I'm working on getting my video back up. That was fascinating, and there's so much there that we could talk about and ask questions about. So I would encourage you to either raise your hand. I know that I have questions, but I want to open this up, of course, to all of our guests who came tonight. If you would like to speak, raise your hand, and then I will also work on answering questions from the Q&A queue, which I see some coming in there right now. So let's
Jesse, should I stop sharing my screen? I don't know how you have, or just leave.
I think this is actually a beautiful slide to leave this on. It'd be more interesting than just looking at the two of us, and here we can see your screen and then both of us. So let's just do it that way. I'm going to go into our participants now, and I can see that Larry has raised his hand. Larry, I'm going to allow you to talk. Thanks for coming.
Hey, thanks, Jesse. Hey, Steve.
Hi, Larry.
Just a quick question. I think I know what you're going to say, but given the long history of physical removal efforts of urchins, what do you think about the future prospects of using similar techniques, and what do you think about the effectiveness of that in the future in Oregon waters?
Yes, Larry's a good friend and an excellent subtidal ecologist, and knows much more about these systems than I do. And so thanks for asking me that tough question, Larry. But yes, so as Larry's pointed out, Oregon has had 30 years or so of pretty heavy harvest of removing urchins. You know, as I mentioned, 10 million pounds per year coming out back in those days. 100 businesses supporting that. So we've physically removed, you know, millions of urchins out of there. And so that has diminished now down to a small artisanal type business. And we could, you know, mount efforts to up the take for science, up the take physical removal for conservation purposes. But even that is going to be, you know, nowhere near the effort that was put in by 100 businesses working out there in the past. We also put together proposals along these lines, just anticipating Larry's good question years and years ago. We didn't get it funded, but I think the title was, "To what extent can the commercial urchin harvesting business mimic the historic take by sea otters?" And we almost got that funded years ago. I was sad that didn't happen. I think, Larry, just to answer the question real quick, I think it can be effective on a small scale at particular sites. You know, within a particular cove or surrounding a small offshore rocky island, something along those lines. But to tackle this, try to make a dent in the populations along the whole coastline, virtually impossible with the scale of manpower and the finances that would be needed to do that. You know, you could imagine getting a urchin smashing or an urchin conservation, kelp conservation brigade, 5 or 6 vessels and 20, 30 dedicated people going, but that would still be very small in comparison to what has historically happened in terms of the removal. Really is driven by the market, the commercial market for urchin sushi, urchin roe is at an all-time high right now, $3 a pound, unprecedented. And we do have a very viable business going on here. So, you know, as the market goes up, more and more people will get into it. So we're also looking to see, are there any barriers to the retail marketing side that could be reduced that would perhaps provide an incentive for some greater harvest.
Great, thank you.
Yeah. Larry, as I mentioned as well, also had a very close relationship with our shared professor in Santa Cruz. So he's thinking about those same problems. Jesse, I think your microphone is muted.
Thank you. Thank you. I was just saying, thanks, Larry, so much for your question. And also, we have many, many questions, and I'm going to kind of skip ahead because it looks like some of those questions about sea urchins and harvesting might have just been answered. The few of you who asked the question about that, if that was not answered, go ahead and raise your hand and we can get into that. But I'm going to skip ahead because we have a few questions I've noticed about kelp harvesting. There's a couple of questions about, is commercial kelp harvest allowed? And is there kelp harvesting happening? Some of you could speak to that. We have about 4 questions about that.
Yes, so right now in Oregon, we don't allow commercial harvest of kelp. Long-termers will remember that we historically did allow commercial harvest of kelp along the Oregon coast. And that we took steps when that became evident that it was problematic to limit that and allow it only in an experimental kind of way. And then when that harvest contract expired, we did away with that. So we don't allow commercial harvest of kelp along the coastline, nor do we allow commercial harvest of seaweeds from the intertidal zone. We do have a commercial seaweed harvest operation in the Southern Oregon coast, but the actual harvest areas are located in Northern California. So right now, no commercial harvest of kelp, no commercial harvest of seaweeds. Personal harvest, okay, but not commercial.
Thanks for your question. Let's see. I would think I will go to the participants to see if somebody has raised their hand. Look really quickly through here. Ingrid, I have allowed you to talk, so go ahead.
Hi, so I was just wondering, how can we inspire marine conservation work among high school students? What kinds of opportunities are there to help out and for people to get involved?
Yes, excellent question. Thanks, Ingrid. We do have, opportunities are typically offered through organizations like this, through Coast Watch, and Jesse should talk about that. Sometimes the marine stations will have internships for individual mentorship, individual opportunities. The Sea Grant program has a very strong outreach effort that reaches out into the classrooms, typically aimed at younger students, but at the high school age, either offered through your school or through programs like ACE, the Apprenticeship in Science and Engineering. I always enjoyed mentoring high school kids, students, young adults, when we had that opportunity. There are some concerns about getting out into these areas because it's dangerous in the Rocky Intertidal Zone and even more dangerous in the subtidal zone. So there are some concerns about access to sites. Yeah, there are some programs like Coast Watch, the Limpets program, which provided instruction in natural history, and other programs along those kind of lines. Jesse, you want to say something about opportunities there?
Yeah, absolutely. Ingrid, thank you for that question. It's a question that a lot of us in this field are always asking ourselves. And we have a number of ways that you can get involved. And we also are involved with partners like the STEM program. I don't know if you're aware of that, but that is a great way of students connecting with the sciences on the Oregon coast. And I have to say that with the Coast Watch programs, we encourage mile adoption and also the citizen science programs. We have schools that work with us to get to the coast when they can, and we are actually currently working on how we can partner with schools and with other organizations to get students to the coast more often, even coastal students. There are a lot of opportunities with us and then with other organizations, with marine reserves, for students to be involved in citizen science programs, everything from beach birds and Seastar surveys, Seastar observation logs, all that kind of a thing. So I would love to talk with you and connect you with some folks that could possibly help you. And there are so many, as like in this pandemic, I mean, I can tell you that many of us are now online, and the availability of these programs and webinars and all that kind of a thing through our aquariums is just increasing. And it's incredible what you can find online for your students for free. So yeah, please contact me after this if you would like to talk more. All right, let's see, more questions. We're gonna go, we'll go for till about 7:30 tonight. Let's see. Okay, here's a question. At Rogue Reef, where urchin harvest has declined, has there been a change in kelp cover as a result of the decline?
Yeah, so good question. Rogue Reef is one of the places where the kelp has actually increased, and it's the site now for the persistence of the commercial sea urchin fishery. So we have a healthy-ish kelp bed at parts of Rogue Reef, and that's where the commercial urchin harvesters are working. The urchins that they're harvesting from Rogue Reef have intact gonads, so they're marketable, and they're drawing that high price that I mentioned of about $3 a pound.
Thanks for your question. Corrine asks, is there either commercial or restoration aquaculture of kelp in Oregon? That was one of my questions as well.
I'm not aware of any aquaculture of bull kelp or other seaweeds for conservation purposes in Oregon. We do have mariculture, commercial mariculture of seaweeds, of dulse, going on at 3 locations, down at Port Orford, on the dock at Bandon, and now also a new growing business up on the dock at Garibaldi, up near Tillamook. But those are tanks of seaweed grown in an enclosed tanks, kind of like the size of the recreational sport swimming pools that you can put up at your house. Growing that for food, for human consumption, not for placement out as a conservation aquaculture product. It's a good question though, and we are asked to consider that, and we're considering, are there places where we could perhaps gain access to the spores and perhaps small bull kelp plants and deliberately outplant them, but I'm not aware of any effort taking place along the Oregon.
That's a very good question. Thanks, Corinne. I had a question. I thought it was very interesting that the population at Depot Bay of bull kelp has not seemed to change. Can you talk a little bit more about that, Steve? Has it grown at all? Is it the same area? I mean, because I've noticed when I drive past there that, yeah, it seems to have been the same for years and years and years. But I've never really seen a drone shot from above. Has there been any change at all? That's so interesting.
There's some variability, but overall, the technique that Sarah Hamilton, the graduate student, has been working out to use satellite images to try to figure out the spatial extent. There's been variability in the imagery, but overall, there's been no directional shift towards an increase or a decrease. So it's variable over time, certainly, but the records that she's been able to assemble so far have shown that it's been pretty static. Small scale variability, but no directional change.
I know that there's a habitat refuge area near there, and it's a fairly protected cove, and I'm wondering if that has something to do with that population being so stable.
Well, it's possible. So that's Pirate Cove you're talking about there, and Pirate Cove is a protected area, so there's no harvest. The commercial harvest of urchins, which you would expect in areas where there's a lot of harvest of urchins, may allow and free the kelp to grow. There has been a commercial harvest of sea urchins along the rocky shorelines at Depot Bay, but it's been very small in comparison to what's going on in the southern Oregon coast from Port Orford south, from Cape Blanco south.
Okay, interesting. All right, we have a question here, and I like these basic questions because these are always good for those of us who don't know and reminders of others. But we have a question from Bob, and he asks, kelp versus seaweed, are they the same?
Yes. So I've been trained up to use the term kelp for what we're looking at here, these brown algae that have stipes and grow up, big, massive canopy forming algae, marine algae that we know as kelp, and seaweeds as the understory, smaller marine algae that are down below, closer to the bottom, and that can include the fleshy types that move around. This photograph shows some crustose and erect coralline algae, which are another type of marine algae, not necessarily seaweeds, but kelp are really those that reach up, not quite always to the surface. They form a 3-dimensional canopy in the shallow subtidal zone, and the bull kelp in particular reaches all the way to the surface and has a float and a large stipe and blades that float up on the surface. So I tried to not use those terms interchangeably, but just recognizing where they are in the water column, close to the bottom.
Thanks for your question, Bob. Let's see, we had a comment from Larry, and I think this was in the context of Ingrid's question. And Larry reminds us that current efforts to designate rocky habitats includes proposed development and implementation of volunteer stewardship programs for people of a wide range of ages and backgrounds. And he's right. And a lot of these efforts are, a lot of these proposals may be including kind of educational components to these areas, which are very interesting and fun to think about. And so, Larry, thank you for reminding me to include that in this presentation and in that answer. Let's see. We have a question about mussels, and I think this question is in the context of some of your slides, Steve, that were showing the increase of mussel populations, the decrease of the sea stars. And she is asking, do you think mussels should be harvested throughout the Oregon coast? And she says, even in the reserves, and that's an interesting question.
Well, the marine reserves are designed as no-take reserves, and so those are deliberately set up so that so we don't have, heavy-duty commercial harvest to contend with there. We do have the ability for commercial harvesters to collect mussels and sell them as a product, but we allow that only in certain places and control the number of permits. So we do have a commercial industry, and then the recreational harvesters can take mussels from many locations, not all, but many locations for personal use. I do that. I like mussels. I want to caution every time I talk about eating mussels, I want to caution everybody to always check the shellfish hotline, because mussels in the Rocky Intertidal Zone are subject to contamination by marine biotoxins. They're filter feeders, and they feed on the phytoplankton that's in the surf zone. And the phytoplankton in certain conditions can develop marine biotoxins, domoic acid, and the mussels will pick that up, or paralytic shellfish poisoning in addition to amnesic shellfish poisoning. So it's always good to check before you go harvest. So should we allow it everywhere? I would say no. We want some special management areas. But should we allow recreational harvesters the opportunity to go harvest, healthy mussels? I say yes, for a couple of reasons. It's fun to get food, and it also leads to that awareness of the tides, the care in recognizing species, recognizing the communities, and it really puts you in that spot where you appreciate the Rocky Intertidal Zone when you're going there, and we'll feel that, hey, this is some bounty. I can collect food here. Same kind of thing when you go out hunting mushrooms or harvesting berries. You appreciate the surroundings and the productivity and the bounty that our wonderful communities have for us. So I feel the same way about harvesting mussels and gooseneck barnacles occasionally, and collecting razor clams and going crabbing along the coast and digging up bay clams. I like to do that, and I think it's a good, healthy thing for us to do. It's nutritious and puts us out into contact in the world. But I recognize that we don't want to do that everywhere. It's appropriate in some places and not in others.
Balance is key, as we are learning, as we know. All right, well, I think we're going to ask one more question because it's important and it relates to this presentation tonight. But John asks, how can we support efforts to reintroduce sea otters?
Yes, so there has been quite a bit of interest and even action, as I mentioned, in the past years. And so at this point, there's the efforts to look into the feasibility are being supported and facilitated by the members of the Alaka Alliance. So if you would like to get involved in that, the Alaka Alliance, perhaps Jesse, you can circulate that around.
Yeah,
as a website, they have opportunities for webinars. They're hosting symposia. They're undergoing the process of developing a feasibility study. I think they're getting started on an economic impacts study. They've got an advisory board. So there's opportunities to learn from them and also to contribute ideas to them as they move forward. Very complex process, as you can imagine, bringing in a top-level predator into our systems. But it's a situation where we have to recognize that we're operating without the presence of that top-level predator. And perhaps some of what we're seeing might be a kind of a skewed ecological norm that we got used to without.
Looks like our stream is being interrupted. Okay, I've just added the Alaka Alliance website. That is a great place to go to learn more, and also you can get on their newsletter, and they have a number of webinars that they have done that I think that you can access on their website, and they will be continuing to do outreach and presentations going forward. So with that, thank you everyone for your questions. If there was a question that you asked tonight that could not be answered because of our time constraints, you can contact me. You can also contact Steve. Could you let us know? I could type your address right now into the chat.
Sure.
Remember,
So my email address is my name, Stephen with a V .s.rumrill at state.or.us.
so please feel free to contact Steve with your questions. It's his job and he would love to get back to you. We have many thanks and messages of gratitude right now. Steve, I don't know if you can see them in the chat there, but people are just loving this and thanking us for this excellent presentation. And I am very grateful that you are here tonight to present to us as well. Thank you for taking your time this evening. Everybody, this will be available on the Coast Watch YouTube channel, and that address is very long. I cannot share it at this time, but if you would like it, I will send that to you. Just send me an email. I'm going to put my email into the chat as well. It's jessie@oregonshores.org. See if I can type that. If you go to our YouTube page and you like it, then eventually once we get 100 likes, I'll have a very short, nice, tight little address, and it'll be like youtube.org//coastwatch or something like that. Then I can just say it. But if you Google Coast Watch YouTube, it should come right up. We have a number of videos on there right now. So thank you everybody for coming, and have a wonderful evening. And Steve, thanks. It was really great to see you tonight.
All right. Yeah. Thank you very much for the opportunity to share this story. And I appreciate all the good work you're all doing up and down the coast.
Okay. Thanks a lot. Take care, everybody. Good night.